So Biomimetic Footwear V1. Really looking forward to this one. This webinar will be using Rhino and Grasshopper with Pufferfish, Parakeet, and Weaverbird, which was really cool. I actually discovered Ping's work because of his using Pufferfish, which I wrote.
Yeah.
So that's my plugin, and it was, I think, one of the first people I saw making footwear designs with it. So thank you for using my plugin in such a cool
Thank
way.
you for creating them. It's pretty cool, really.
Yeah, you're welcome. Yeah, I'll introduce you. So Ping is a founder at the Liveform. If you don't know, which I believe you just started, right? Recently.
Yeah, I just started like the first
Yeah.
release of the brand. Yeah, just started.
So that's like kind of 3D printed footwear company, yeah.
Yeah, exactly.
Yeah. So Ping is based in Tokyo, Japan, originally from Singapore, and graduated with a degree in product design. He has 6 years experience working in branding and packaging with clients like Procter & Gamble, Macallan, and Adidas. His true passion is in footwear design, which led him to join competitions held by Pencil, actively posting works on social media and working with different footwear brands before starting his own brand. And I believe you also launched an NFT collection as well, right? With
yeah.
Yeah, so that was also really cool to see. So let's get back here. If you didn't see the message that we posted in here, there are some files you can download to start. I'll post it right now again in there. And make sure you switch your chat to everyone, otherwise you're just writing to me. And if you have any questions, please use the Q&A button. If you look where all your Zoom buttons are, there's one that says Q&A. If you ask it there, it will be easier for us to keep track of so it doesn't get lost in the chat. And then just a reminder that the webinar, as you know, is recorded. You know how recording access is emailed afterwards, as described on the website and the registration form. And just keep in mind that not everyone learns at the same pace. So if you're having trouble keeping up, just remember that there is recording and files that you can go back to. Of course, ask questions, but we may not be able to stop for every little thing as we get through the information and content for everybody. Yeah, I'll hand it over to you now, Ping.
Yeah, thank you, Michael.
Yeah. And I'll be here the whole time, so no worries.
Sounds good. Yeah, so maybe let me get a little bit into like the introduction of this webinar and what I'll be sharing with. So basically, Biomimetic Footwear version 1 is kind of an exploration of parametric modeling and traditional modeling, like traditional modeling in the sense of, I think, more like surfacing and NURBS modeling in Rhino and parametric in Grasshopper, right? So this way we're kind of exploring avant-garde footwear concepts. So I'm gonna share like how I take an idea and concept and kind of turning it into an actual design. So from my personal experience, like I find this like the best way to learn, at least for me. Like I kind of create a design, then from the design I try to figure out like what are the, because like in Grasshopper it's kind of like a endless sea of like plugin, and there's so much things you can get access to, and I think I sometimes find myself lost in it. So like the way I do it is I try to figure out what I want to do. Then I try to sort of like reverse engineer or, find a way or find a plugin that kind of suits what I want to create. So I think this way kind of facilitates me, because like there's like so many things you could learn, and it's kind of like not possible to learn everything. So I think if we were to kind of look at what we want to create, and then we find the ways to create it, then maybe that way we'll have a more effective learning. So that's why I kind of wanted to start from the start, like a concept, to the end, like doing the geometry, to like rendering, and using that as sort of like a concept design. So yeah, so basically what we'll be using, we'll be taking like a lot of inspiration from nature, and like generative like growth, or patterns that's kind of more unexpected, like it's more similar to how we find in nature and organisms. So we'll be doing the base model in the base, as in the shape in general, in Rhino. Then we'll be taking it into Grasshopper to create the patterns and all the detailing. So with Grasshopper, so we'll be using like sub-D modeling, which is native in Rhino, so you don't have to download that. But what you do need to download, if you have not, so maybe you could quickly do it, download that into your Rhino, so that when you turn on the what's that called, when you kind of open the file, you could kind of see that working. If not, you'll be stuck because it's not gonna work. So like the ones I'm actually using is Parakeet, Pufferfish, Crystallon, Weaverbird, and Lunchbox. So I think I am short of. Let me just share screen right now so you could see which are the different plugin that you need. So you could quickly, yeah, I can just type it real quick. Can I still access the chat if
Yeah.
okay, yeah, cool. Let me just type that real quick. So to make sure everyone. Yeah, so it's gonna be sort of like mix and matching like some of them to create the desired outcome together. So I think I will just explain more in detail while creating the design as we move forward. Yeah. Then okay, cool. So maybe I can start with the design concept first. So I think in general, I would usually start with sort of like the idea. So I think for this is kind of like biomimetic. So I really wanted to kind of look at how to create design that's inspired basically by nature. So I chance upon this kind of like image of like I forgot the artist's name, but basically what he does is taking sort of like he dyes the bones of like fishes and take photography of them. And I thought it's really interesting, like seeing the structure of the fish. I thought that's kind of like a great start for design. And also I think you probably do see like fishes that are transparent, or like fishes that are when they are like just born, they kind of look translucent or transparent. You could see like the inner workings of the organs and bones. I thought that's really intriguing. So that kind of transparency kind of reminds me of then, like obviously like this is a course about footwear, right? So that transparency kind of reminds me of like Cinderella glass slippers for some reason. So I thought that's kind of interesting. So I thought, oh, how about like the footwear that's kind of like resembling glass, and you could kind of see the interiors, like using transparency to see the interior like patterns or design of it. So that's kind of like how I came up with the concept. So if you can see, like this is sort of like the sketch render. So what you see is sort of like a whole body, a body. So it's kind of simple. So it's just like a body shape of the a high top footwear, and then you have like sort of like two pairs of like wings like structure. So we're gonna be creating this first in Rhino using sub-D, followed by like the detailing of the patterns and other like where the midsole is in Grasshopper. So yeah, so if you were to open the file, you'll be able to see the you can see there's like a couple of like layers. So there's this like concept layer. So that's kind of explaining what I've been so far. Then we've got like the guide. So like the guide, there's a few layers. There's curve, wing, wing one, wing two. So with curve, so when creating designs in general, like with footwear, it's good to start with it's good to start with like sketches, especially lines as sort of like a guide for you to kind of work on, so that it's easier for you to kind of create your designs than to get lost. And another thing is that usually, I'm not sure if you guys are familiar with like making footwear, but there's something called a last. That's what actually is used to make the shoe base off of. So it's a last is something that resembles your foot, and you know the shoe is made around it and it's sized according to that. So usually when you create a wearable footwear, you definitely need something like when creating in 3D as well, you need something that's called last. But in this case, since it's sort of like a conceptual design, we don't necessarily need it. But still, I sort of like drew it out. If you see from the front view, so that's the outer line, is sort of like the body. Then you have the sort of inner line. So that's supposed to be the last. So here as well. So you see sort of like a thickness. So I think using this, we could start designing. So maybe let me just go through with you real quick about the sub-D tools. So if you're not familiar with sub-D is basically a tool that's more recently available in Rhino that allows you to model organically. So previously, it's actually quite difficult to model in NURBS, something that's more organic, but previously they had T-splines, but now they have, I think, fully integrated like sub-D modeling as a replacement for T-spline. So that's, I would say it's quite intuitive to use. So basically it's basically made out of, for example, I could just show a couple of like demonstration before, for starting modeling. So you kind of have these different faces that constitute like the sub-D faces. So this is where I created a cube. Then you could, so there's two modes that you could see. So first is kind of modeling it sort of like the base shape. The base shape is sort of like a hard surface. So they're kind of like there's no curvature or anything like that. But when you toggle it using this button, you could toggle between the sub-D display. It will show you this. So this is the final result of your sub-D modeling. So this gives you a lot of freedom to create like really flexible designs. For example, if you can extrude using this using the gumball, like this circle button, you can click and press on it, and when you toggle, you can see like it becomes really you can create designs like that. So now you see like the correlation, or like or rather how it is really suitable for footwear design, because like previously, as you know, like foot is something that's more how can I say, like the shape is a little bit more organic. So this is something that's really suitable for that. So basically that's kind of like the basis of it. So you could create like different starting shape. You have sort of like a cylinder. You could use it to kind of define how many like little pieces faces that you want, and that kind of creates sort of like a starting point for you to create your design. So these are like sort of like all the basic geometry that you can use. So I'll just create the design, then as I create the design, I'll kind of as I go along the different kind of functions, I think I'll explain that along the way. So I think that would be easier. So whenever I create design, after doing this sketch, I find it helpful. Let me just create one more layer. So for me, it's helpful to actually model it from the top view, creating the sole first as a starting point. So for me, the way I do it is I'll take a sub D plane, create sub D plane here. So you could just create this. So as you can see, it's sort of like just a square, right? So what I do is you see this outer line of the shoe. So what I do is I will match just from the top view itself to match how this looks. So you could just basically it's very easy because you could just almost gumball everything. So you could Command Shift and you can select the faces. Select you can Command Shift, you select, and you can select the faces. And you can start like moving very easily. So there's two ways of viewing it, right? So if you toggle it, you can see like the base is just like really simple, like made out of squares and rectangle faces. When you toggle, you see like the different points. So what I'll do is I'll try to match. So you can Command Shift. If you just select like a small area, they'll click on the point. So you could use that to kind of move. So I'll try to be as accurate as I can. So what I'll do is, okay, so now we need more space, right? So more like surface. So what I'll do is like Command Shift, click the two edges, and I'll use the red gumball button to kind of drag, and you'll see the face is extended, or not extended, but kind of like additional faces added. So that is useful. So I will create the design. And continue to drag and pull. So this way, to me, feels really intuitive. So if you guys are familiar, I'm not sure if you guys use another software called Gravity Sketch. So the logic is very similar as well because they use sub-D modeling. Gravity Sketch is a VR sketch. You can also kind of check it out as well. And I think a lot of footwear designers are using, without modeling experience, are using that. So yeah. And, Also, if you were to, you see, like I wanted here to be a little bit more accurate, but I already like created all the division, like the different like faces. But I wanted to add one more. So what I can do is select one of them, and what I can do is click this, insert sub the edge. So it creates an additional edge. So using that, you can, add to it. So I will, scale this down. Yeah, so this is looking pretty close. So maybe we could take to the front view as well. So put it down and let's try to match it from the side. Right, so you have something that sort of resembles from the side view. So from there, you can see like the perspective view. Yeah, so you can also click on like directly click on the control shift and click on the like edges, faces, or points. So what I'll do now is basically, you have the base or the sole already done. So basically what you need to do next is to create the rest of the body. That's where I kind of need to extrude out to create all these surfaces. So what I'll do is same thing, Command Shift. Oh yeah, by the way, I'm using Mac. So if you are using Windows, I think you might have to, I think it's Shift Alt. It might be Shift Alt. Try that. So okay, so select the edges. Command Shift, double click. When you double click, you'll auto select. You'll auto loop select. So what you do then is gumball. You can click the round button, and that will extrude. You can extrude more. Extrude one more time. And let's go to the side view. So sub D is mostly just using gumball to kind of move the parts to get what the effect that you want. So sometimes I also check when I toggle it back to sort of like the hard surface. So to clean it up a little bit, because like it's over, if you see it from here, it's a lot of overlapping, like it goes underneath, like the first, second, the third line goes into like the second, goes inside, right? So I think that geometry is not so clean. So what I'll do is I'll do some adjustments here. Same for here. And so sometimes it helps when the geometry gets too complicated and you don't really understand what's going on. It's good to toggle back. That gives you it's sometimes easier to view it in this mode. This hard edge mode. Yes, all plugins are available for the Mac system to answer some of your question. Yeah, because I'm using Mac, so they're all like available to use on Mac. So you just have to download them and kind of put them in the component folder, and they should work fine. So like visually when you see this, using kind of like the hard surface, it looks better, and when you toggle it back, it's also cleaner this way. So that's what I'll do. You cannot, sorry, Dylan, you cannot see the sketch lines. It's under guide curves. If you turn it on, you should be able to see them. Yeah. So it's basically just, extruding and scaling and extruding for the most part that we do for on the side view. I think after going to the perspective view, we'll do some tweaking again. So if you were to toggle it back, it actually looks pretty close. So I think we are good. And now here looks a little bit funky, right? So the thing is that we still have let me change this to this layer. Turn on this, just like as a reference, so you can see like where's things going. So you can see like it's supposed to be a lot slimmer on the shaft here, this area, but currently ours is like way too fat. So we need to take it down a notch. So it's easier for me personally when I model it in this view, in this not necessarily the smooth view, but sort of like the one with the edges. So I'm just trying to get everything round and smooth. Or like this whole edge look continuous without like so much zigzags. Then I will scale the whole thing. So generally the top part tapers a lot more. So that's what I'm trying to do here. So sort of like a, on the bottom is where it's the widest, as it kind of moves up, kind of tapers. So the whole area is going to be tapering. So now they're kind of slowly evening out. So after I sort of like round it like this whole area, not rounded, but like this curve is smooth, you could start to just scale the whole thing until you start to see the red line. So if you see it from this view, because I already sketched, like your foot is asymmetrical, right? So the way the shaft leans, it's also towards the medial side of the foot. So you can see this going more towards the medial side. Oh yeah, sometimes sub-D breaks. I think that's a bug. But if that ever happens, so when you move, sometimes it just breaks, and what happens is that your whole sub-D model will disappear. But you don't have to worry. All you have to do is just Control Z or Command Z. I'm not sure if that happens for a Windows user as well, but it happens to me quite often while using Mac. So we're kind of like equal to kind of building a foundation for what like the data that we're going to be using for as an input for Grasshopper in Rhino. So well, if you were to create this, yeah, you'll be getting something like that. And now you can see the detail of like the red curve, like the red side view curves popping out. So you can start to add some detail. So one of the first detail that I will be adding is a crease. So basically a crease is that you can see like the surface are all like continuous from this view. And when you toggle, like these are like edges that are hard, right? So they're creases. So this is the final view of the shoe, but the bottom of the shoe is flat. So like I wanted a harder edge, like a crease to it. So what I'll do is, so about from here to here, this area will be a hard edge. So what I'll do is, I'll select these curves. Okay, so another tip that's helpful is that if you Control Shift or Command Shift, double click, you'll be able to kind of access the curve, the loop. But when you click one end to, if you don't want to click everything, you could click one end to the other end of where you want, and then you double click in between, and that would help select them for you as well. So you click the top and the bottom of the start and the end of the loop of edges that you want, not the whole thing. Then you can double click in between, that will help select them for you. So what I do is add a crease now. So if you see this is add crease, and the other one is to remove crease. So now I'll add a crease. So now you see like the shoe is, this area is really defined and flat. So now we can do a little bit more detailing. So like the red areas, can extrude a little bit more. So, you can see there's a gap. What I'll do is I'll move this. Get something closer. It's longer. This seems to be going inwards. I think this is pretty close to the design. Yeah, I would say that's quite close. And then we want to create, like, you see a detail, this detail where it kind of folds in, and that's kind of like the entrance where you put your foot in. So what I'll start to do is I'll take off this these faces that creates the kind of like the gap. So around here, I'll just take off all these. So I'll just select the faces and delete, and you kind of see a like entrance, like a gap. Delete where it's appropriate, and then I'll just try to match this. Because maybe what I'll do is go back to this. Right, you see that kind of like broke, so that's a bug. So just Control Z. So do you guys kind of, I think it's quite straightforward, right? So you guys can understand this so far. I think it's quite straightforward. Okay, cool. So if this is so I think in the essence of time, so instead of creating everything sub-D from scratch, I think this is a good enough demonstration, I believe, to understand how to kind of use the basics of sub-D. So great to hear you guys are, enjoying like this process so far. Yeah, this could be actually, this process can be a little bit time consuming, but not exactly sculpting itself, but this is, somewhat similar as compared to NURBS or Grasshopper, like parametric modeling. So you kind of have the design. Yeah. Toggle it, you can see like the shape is forming pretty well. So that needs to be true, like the shape needs to be. So yeah, so that's kind of like more or less the shape, not including the last. Can you cut this? Yeah, right. For Daniel, like, could you cut and trim the sub D? You can't really cut or trim sub D. You can cut or trim, but what happens if when you do that is that it will immediately become a NURB surface. Then it's not backward editable. So with sub D modeling, you have to really, just do that. You can't really trim or cut like how we usually do it in Rhino. You have to, pull, or you can delete faces, but you cannot just trim it as it is. Yeah. So like for the lines, these guides are these are designed by me. So I draw the guidelines, but that's actually what you would draw for yourself when you do design, when you do footwear design in general. So it doesn't even need to be like parametric modeling or what, like even like regular NURBS modeling. It's people would like draw lines as designers would draw lines as a reference when they start design. So that they know like what they are trying to do. If you model something like that, could you convert the NURBS file to sub-D for further editing? What would be the process of drawing these lines? Sorry, let me just answer Catherine first. Like if you model something like that in Rhino, could you convert the NURBS file to sub-D for further? This is actually sub-D already. This in itself is sub-D. So you could change, change that into, if you do this, convert file to NURBS, you can convert it directly to NURBS. You can also, so what happens when you convert to NURBS? This is what happens. But what's tricky is that you cannot you can only do it one way, if that makes sense. You can't really do sub D. You can do sub D, always the starting point is sub D, then you convert it to NURBS for the editing, like trimming or whatever else you need. But you cannot really convert it into the exact exact way these faces are being placed, or the topology of this will not be the exact. So you can actually, what you can actually do to change NURBS back into sub D is actually to do a quad remesh. Like it's not sure. Like I don't have a NURBS object now, so like it doesn't show, but you could do a sub D remesh. You could remesh a NURBS model, and it will give you an approximation based on the number of like faces you want to give. So like obviously the more sub D faces you kind of type in, the more detail or the more accurate the sub D mesh will be. But the thing is, at the end of the day, the topology, it will not be as clean as this. This is like very like well organized. Like you can see like the bottom face, then you can see the extruded faces like horizontally from the side, but you won't be able to have such a clean kind of topology. So which is why it's tricky. You have to model it in sub D first and have that finalized before, because that is the most editable geometry kind of phase. Then you move into NURBS modeling. Like if you want to blend surfaces and everything, you could still do that. The normal commands of Rhino, but you have to make sure that's your kind of like your final form before you kind of move forward to kind of edit it, basically. The process of drawing these lines would be actually just, you could just quite literally just draw curves on the different faces. Then okay, basically I'll just do a really quick and dirty way of creating the last, because it needs a interior shape, right? So what I'll do is I'll offset the object. I'll just offset by like 5, not have it solid. So you can see this shape, right? So what I'll do first is I'll hide this. The external shape, I'll hide it. I'll take this edge, because the inside it's not a kind of like, it doesn't have a sole, so it doesn't have this hard kind of edge. So I will remove the crease and try to match it to this. I think for like a concept model, you don't have to be so concerned about the accuracy of whether it fits a feet. Is it better to model low poly? In terms of sub D, if you can model it as low poly as possible, that would be the best, because you will get the cleanest surfacing as well. Just in general, like less is better, right? But of course, like when you start to add details, it gets complicated. So like this model itself that I'm I'm showing you, it's actually really simple. I think it's really basic. So you don't really have to you don't really have to create a really complicated form based off the design, because the design itself is simple. So here you could just scale the whole thing. Scale down. Right, so you can see sort of like oh. So you can see like the interior is done as well. So what you want to do next is actually merge them together. So what I would do is I just toggle it back to the original form. So like the same thing, you could double click to form the edge, right? So what you want to do is kind of stick these two edges together. So there's two ways of doing it. First is to bridge. So you add an additional face in between these two edges. So what you do is you select the first edge, so you can double click. Then after that, you can double click again. So what you have to make sure is that the number of edges need to match in order for this to work. So with sub-D modeling, you need to be accurate in terms of the faces need to match in order for parts to join. Oops, sorry. Again, first, enter, second, enter. So it'll tell you how many segments you want. You can increase it, but we don't need that. So you could just join. You can add crease if you want, but we don't need. So this way, the whole part is joined. So you can see like a whole surface here. So yeah. So that's more or less the exterior shape. Then you see the guide. So we have curves, then we have wing 1 and wing 2. So I mean, like, it doesn't really make sense you see from the perspective view, but basically you're supposed to have like two pieces of wing here and here. So I think that would be next. So I think if you were to open the sub-D layer, you'll be able to see the result. So this is the first, the bottom fin, and that's the top fin. So that's the body where I just modeled it. So do you guys need me to also demonstrate how to create the fins, for example, this? If not, I'll try to, in the essence of time, you can take a break. Then I'll show you how to work them in a Grasshopper next. Okay, I'll just show you how to create the wings real quick. I'll just show one wing. Then you could just model it, mirror it, and you have the other side of it. And the other one is just pretty much the same. So okay, so let me just turn off. Go back to our model. So guide. So same thing, I would start with this surface. So what I'll do is, it's easier to match from the top, like this top, like cross-section line. So that's what I'll do. Yeah. So now you can see it's just 1 second. That is half of it, and this whole edge is creased. So sorry, it's not creased, but that's kind of like when there's a naked edge, you'll be creased. But here it's rounded, but if you were to mirror it, it needs to kind of match, right? So what I'll do is, for these two sides, you click on the points and you create a crease, and there'll be sort of like a hard crease. So with this, you could, try to match the geometry. This can be a little bit tricky when you're trying to match. You need to see it from like different perspective in order to kind of match them together. So, another way is to, just create everything from one perspective, and then you try to match it to the other ones. Which is what I'm trying to do now. So I'm just trying to extrude. We'll go for a short break after this part is done. Is it better to make from the top view and not from the front? It's really up to you, like which perspective you want to make it from. Sometimes it's easier to make it from top view and not side view. I think for this case, it's actually easier to make it from the side view, mainly because my sketch is from the side. I didn't have a top view sketch. So that's why it's easier to make it from the side view. But if you were to sketch your design in from the top view, then yes. So I create like a hard edge. So that creates so now you see that this is slowly coming together. So maybe assign this into a different view. I'll change the layer object and change the color too, so it's easier to see. And then now change this object, change the body to this. Yeah, and I'll lock it. The reason for this is that you don't need to be worried about accidentally like clicking on the body layer and shifting the wrong wrong geometry. And same for the guide, I'll lock it. So So when you extrude, sometimes when you have a hard edge and you extrude, it automatically, sorry, when you have a crease on the edge and you extrude, it will create a crease as well. So you see that the hard crease will remain. So what you do is also need to remove that crease. It's a bit more. So now I think we can add a bit of flare to the wing. Side a little bit. You don't need the reference anymore. So you can see like half the wing is here. So what we can do is mirror it, but make sure this is flat. Okay. Transform, mirror, so take this edge. So what's nice about sub-D is that light surfaces in Grasshopper, Rhino, sorry. If they match up perfectly, you could just, join them. Click join. No, see, click join. So that's quite convenient. So of course, this design is asymmetrical. So we need to edit the and this point is supposed to be, this part is supposed to be pointy. Just Yep, so there you go. So we have like a pair of wings. The way I'm creating, so the next portion of the class will actually, so I'll be skipping this part of the second wing. Let me just turn it on real quick so you know what I'm talking about. So that's the top wing, the bottom one. Yeah, the one that's supposed to go on the side. This I'll skip because it's pretty much the same in essence of time. So for this, for the next part where I'm creating the pattern, so what I'll do is actually to split this into half, to split this subdivision, sub-D surface into half. What I'll do now is, in order to split it, you can do this. You can extract the surface. So that will give you let me just create trees. So you have two surface because we need to create surfaces like nub surfaces from this subdivision surface. So that's what I'll show you how to create them afterwards. So is maybe I can answer some question before we go for a break. Okay. The weight, thank you. Yeah, the shape is very fluid. I think that's the positive part or the advantage of using subdivision. Then for Daniel, it seems like there isn't any difference between the shoe last surface, good for fitting, and interior. Should we model first the shoe last surface, then the exterior? I think when you meant good for fitting, as in like for wearing, I suppose, Daniel. In general, I I'm gonna take it as that meaning good for fitting as in something that's wearable. I think something like that you'll need a proper shoe last, and you're gonna convert that shoe last into a sub D, then you can use it to model. But if you're just talking about a conceptual model, you don't really need to be so mindful about whether you create the interior first or the exterior first. You could definitely create the interior first as well. Generally, I would do that if I want something more accurate, that's less conceptual. So what you do is also the same thing. You get the interior shape out, you can offset that to create a thickness. Then after you offset that, you can use that to create the exterior shape as well. So I'm doing kind of like the reverse. So both ways will work if you're working on a conceptual model. But if you were to work on something that you want to eventually be wearing it, then you need to kind of do the interior first. Hope that answers your question. Yeah, so maybe we can go for a break. Catal Catal Catalina, uh, I I believe Fatten should be a native plugin. I think let's take a break while I answer this. I think the rest of the people could take a break. Maybe we take since this first part is pretty long, let's take a 10-minute break. So 1:30, about 1:30, sorry. My time is different, sorry. So just 10-minute break. So I think we'll get back after this. Catalina plugin install. Fatten, from what I know, is actually a native part of the Grasshopper. Is your Rhino up to date or Grasshopper? Which Rhino version are you using? That might be the reason why your Fatten is missing, because Fatten is a new, yeah, because Fatten is a new it's part of the new update in Grasshopper for Rhino. So you would have to update that. All right, is everyone back? Oh, great, you found pattern. All right, let's continue. Screen, so that being said, okay, so I'm gonna hide what I modeled previously. I'll try to do everything from scratch. I think that way it's easier to understand the flow. Can you see my Grasshopper screen, everyone? Okay, you can hear me too, right? Okay, cool. Okay, so now I'll hide the guide. Let's just assume that we already did that. We did that for the most part. So you turn on the body, and then you can see the two fins, right? So we did this and we did this earlier. So what we're gonna do next is, so let's assume we did the bottom fin already. So what we're gonna do next is create the shape. Use this shape to create pattern on it, right? So with that, let's hide top and bottom fin, and let's hide this as well, just one side. So one side you can really see. So what we need to do, so we're trying to create a pattern, right? So what we're going to be using now is called Lunchbox. So Lunchbox is sort of like a paneling tool. It has a lot of different functions, but for now we're actually going to use the paneling aspect of this this plugin. So you see that there's like diamond panels, hexagon panels, and whatnot. So basically what this does is taking a surface and breaking it down into kind of like this small pattern and components. So for this, what we need to do is to take the curves. So in order to create a surface, because this is a sub-D, we cannot really just use it as an input because the panel, okay, so let's just turn on like a simple paneling tool. So let's just use quad paneling. So like the input needs to be a surface. So what we need to do is to create a surface out of this sub-D. So what you can do, or what I would do, is, you see, I would extract curves from here. So, you can see 4 curves, 1, 2, 3, 4. Wait, why is it? Yeah, you should be, it's basically like an edge surface, so it's really simple. So you get 2 from the top, 1 from the top, 1 from the bottom, and left and right. So it depends on how you want to break down the curves, but depending on where you select to kind of split the edge of the curve, it will give you, the surface will be, well, it will look different, but also it would be distributing the patterns differently, so that it's also going to inform how the pattern will look like. So maybe let me just hide, let me just show one wing. So what I will do is I would take this top part as one side and side, and this bottom part. So what I did was, what you can do is really simple. You can just what you do is you could just same thing, command shifts, select the edge, and then like here. So same thing. Double click. You click the top and bottom one that you want. Then you double click whatever's in between and you auto select the edges. So what you do is go to standard, just duplicate edge. Super simple, and then you join them. So join into one curve. So here, these three, this bottom one. So extract. Just duplicate which, and you join them. Just type join. So you just want to make sure that it's joined together. What if we extract wireframe from the sub D? You can actually do that. It will give you actually it will help you. You can extract that, but what you're gonna, the finish, what you're gonna do that with, you can actually use that as an input for network surface that will help make the surface more accurate. Okay, so let me just join. Page, join. So you should get 1, 2, 1, 2. So these two should be joined together. And just try to get this page again. Delete the page. Okay, now we hide this. So we have 1, 2, 3. This is really small, 4, and that's on purpose. I wanted it to be less, like the distribution of the pattern to be less equal. So when you have something that's like really long, the edge is really long and some of the edge is really small, you can see like the surface will be sort of like skewed and have to kind of taper, and that kind of creates a really interesting effect when you create a pattern. So this is what we want to do. So we want to get a pattern from we want to create the panels, right? So we need a surface. So what we can do with this, I use network surface. In the example, you can actually also use edge curve, edge surface. So you just like input 4 of them. And I also realized that we could also use something that's maybe even easier from Pufferfish. So if you were to go down to Pufferfish under surface and automatic edge surface. So there's these 3 ways of making. So with automatic edge surface, you could just select all of them and curve, set multiple curves. And you get that surface, right? Then you have like, then you have A, B, C, D, right? That's just like splitting the curves individually. So this is kind of like the most troublesome way of doing it. So I think automatically, what's good about this from Pufferfish is that it helps you sort out the curves, and it knows where the U and V axis. So I'll just stick to this because that's what I use, so as not to confuse you. So basically, U is one direction, V is one direction. So I'll just pick. Well, they have to be opposite of each other, so they cannot be side by side, U and V. So let's take the opposite. It's a little bit like the axis of the surface. So multiple curve. So that's the curve U, and then this two. So opposite, so they don't join, right? So again. And so you see, you get the surface. Okay. So it's a little bit. Also positive imagine. Okay, so now we have a surface, right? We can, plug in. Immediately you can see the effect. So what I'll do is I will hide the previous ones, the network surface function. So you can see like it starts to get a little bit more interesting. So you see when it's cute, like really small, it becomes kind of, I would say the pattern is getting more dynamic as it goes, and it's kind of a little bit more interesting looking. So then there's this U and V division, so you could control how much you want to have division. So let's just say I want the longer part to have more, the longer axis to have more, and the shorter axis to have less. So this is what we have. But what you notice, right? So let me go again. You notice that this is kind of doesn't really match to that surface because it's just like using the edge. So there's two ways of doing it. One, you could use a network surface to create the shape, and what was that just said? Divanish said using the extract these curves to kind of provide additional curve input for network surface. So what network surface does is that it takes multiple curve inputs and as guides to create your surface. But I'm a little bit lazy. So what I will do is, because we already have this surface as a reference, so I think this surface is relatively not as doesn't have so much curvature. So what we can use is this B-Rec as an input. So set one geometry. So we have this B-Rec. So what I will do is, so it still doesn't match. So what I can do is to, let's divide this surface. So like the number of count is really up to you, but the higher the count, the higher the fidelity, you get more accurate results. But I think if you go too much, I think the data will get really heavy. So I think something like that would work. So what I will do next is, what I'm trying to do here is so the surface creates points, right? So you can also construct surfaces using points. So if you go to surface, okay, you under freeform, you go to surface from points. So what this does is that it can actually take these points and input that, and it creates the point, it creates the surface. But what we want is for this surface to match this actual wing shape, right? Which is now, it's not really doing that. So what we can do is we can take the closest point, BREP closest point. So we take this point input and this geometry, this BREP as an input. So you will plot like the nearest point onto the BREP. So previously it was like below, right? But that's not actually what we want. We want it to be, like the curvature is like that. So this is the more accurate way of getting the surface right. So we'll use this point as an input. So whenever this takes the point, it needs to be now you see that the points are in are not flattened, so they are separated. If you were to look at the parent viewer, so it has lots of branches. So this surface from point takes the input as flattened data. So we'll need to flatten it. So let's flatten it here. Then the U count, if you were to plug it directly, it won't be working, because if this U count is divided by the points in between, so you actually need to add an additional 1, because it splits into 20, it splits 20, but there's actually 21 points in the end, so you need to do an addition of 1. So 20, right? You add 1, and that's 21. So there we go. So this surface will match to, oops, sorry, because this is still let's preview of this. So this surface will match with our surface. Yeah. Then okay. So what I'll do next is then I use it to plug into these quad panels. So with the pattern, I kind of wanted a more distinctive shape, like a fin. So sorry, like the bones in the fins of fishes, they don't normally crisscross like grids. Also, what I wanted to use first is I kind of like arrange them in different different Lunchbox components in a specific manner. So I wanted to do the quad panel first, but we'll get back to the the diamond panel first. The quad panels, we'll get back to that later, but we can just use this real quick. It's just like a aesthetic preference. So, this sort of like a diamond shape. So for me, this is so yeah, for me, just now as I was speaking, I wanted the shape to look like fins. So I usually fins don't crisscross like that, right? Like diamond shape or quad shape for that matter. It's just like in a singular direction without crisscrossing. So what's nice about this is that you can deconstruct. So let's just there's like 4 axes to the four edge curves to each of the diamonds. So instead of picking all 4 sides, let's just pick 2 sides. Then you get a continuous flow of kind of like skeletal like pattern. So let me just show it to you real quick. So let's deconstruct. So we deconstruct the B-wrap so we can get the edges. So instead of having everything selected, let's just pick 2. So when you see like each item, let's just say like the face. When you pick it, you see it's like it's getting, let me just hide this. So you can see like starting to create that curve, right? But I don't really want sorry, I meant it would be, imagine it's a diamond, so you want that swooping curve, so it would be this kind of direction of the curve as well as the opposite side. So it's like this and this, right? So you need to select 2. So I'm gonna do addition. So it's opposite, right? So if there's 4 sides, you add 2. I hope that makes sense in terms of like the arrangement. So do shift. There we go. So you kind of get this curve that's kind of more like a like a flowy shape of like the skeleton of like fins of fishes. So let me just add more points so you get more detail. So maybe this is let me check what did I use previously. The input number I was using is 50 and 20. Yeah, because I need to, because it's a very specific effect, so I want it to be a little bit more accurate. So while this all looks nice, nice and all, but it's not really that much like interesting or like I would say like unexpected. So now I think what's interesting is when you try to combine a different plugin called Crystallon. So Crystallon basically is sort of like a lattice structure plugin where you can create different lattices and you fill like forms with lattice basically, but they also have like different ways of manipulating lattices. So like these are like what I'm creating are lines. So lines is kind of like the basic unit of lattices. So what is cool is that it has different ways of kind of manipulating. And so there's particular function called merge curves. So what this does is based on the distance, it will merge the lines together. So let's just say we do 3, like so. I think it's like 3 mm. If they are lesser than 3 mm in distance, 3 or 3 mm, they will merge them together. So this starts to get interesting when you see the parts coming together. So let me just check something quick. Yeah, so this is about right. And in order to give the pattern a volume, we'll be using fatten. So fatten basically is a under mesh primitive. So basically it takes lines or curves and basically fatten it up. So usually before I do this, I would, like, as a good workflow is to clean network to remove any duplicates or because there's a lot of lattice, it's good to kind of have it as a good practice to clean up like unnecessary stuff. And it also kind of helps arrange like the struts, which are the lines, nodes are the points. You can use it for like other like tweaking. For example, when you want to scale them, this like in different proportions, like they have like sphere, you can fatten it different ways. But for now, let's just try this. So now you can start to see it gets a little bit unpredictable, like especially in this area, which makes it interesting. And after that, to make it look even more organic, the shape, we use Weaverbird subdivision. So we use Catmull Clark subdivision. So what this does, it makes the edges not so like hard when it subdivides. So also like, so there's like different like thickness and all. Let me put the input 1. Let's try it. So it becomes slightly thicker because it starts with 1. Then the end type is also something that's interesting. End type means kind of like these ends, like what you can choose. Like I wanted the ends to be a little bit like slimmer. So that's 0, 1, 2, 3. I guess 1 is probably nicest. So it says end type. 1 is pinch, so I think something that's like sharp at the end would look nice. Then when we use the subdivision, it kind of smoothen the edges so it doesn't look so sharp. Let's do one more subdivision. Let's do 2. instead of 1. So now you see it becomes like really interesting, at least for me, that the curves are actually, you know, moving in this manner. When it combines at certain point where it gets really close, so you could get this effect. And what's interesting is also, if you were to remember when we listed the item, we listed these lines, right? So if you were to flip it over, so instead of selecting the like the sort of like the horizontal lines, so let me just see. So we selected these lines, right? What if we selected the other lines? So the opposite of these lines. So let's just try. So instead of 1, we change it to 0. So I believe this is what I was using for my setup. So now this becomes really interesting. So this is just one side of the wing, right? So we need to do the other one. So what I'll do is I'll just duplicate this real quick. Okay. So in. So yes, replace this with this. And just disable everything first. 1, 2, 3. So I already set this up as well. So 1, 2. So same thing, let's just replace the curves. 1, 2. Then here, here. Set multiple curves. This. Okay. And enable. So now we have this curve, but they're not exactly matching, right? So we want to sort of like it won't be a mirror shape. The pattern won't be a mirror shape, but what we can do here is to actually select the other side of the same thing what we did just now. So selecting this edge, right? So now it's sort of like vertically, but we kind of like want the horizontal flow of the lines. So instead of 0, we click 1. So you get these 2 lines. It's pretty, I think, pretty interesting already. Like even though you know they are sort of like mirror side of the wings, because of the slight difference in geometry, the merge lattices kind of work differently. So you can see, like, even though it's the same, it's kind of like a mirror wing, it kind of looks different. So I thought that it's kind of like very interesting as well. So now they are kind of like separated, right? So what we wanted to do is have it kind of in one piece. So what I'll do here next is all these from networks, clean network and all. So this will be, let's do the same thing. So we've got 2 set of lines. So I would merge them. So these are the lattices. Oh, my bad. We should move 1 step back. list item, just the curves itself. I'm not sure about clean network. I think if it doesn't work for you now, I think it would still work without. I'm not 100% sure. Maybe let me just look it for you during the break. Yeah, for clean network, I'm not 100% sure. Okay, so let me get back to you in a bit. So basically, we wanna first merge these two curves. So instead of uh doing individual parts and using the Crystallon merge curves, we would first merge the result of these two sides. Then we put that as an input for merge curves, because these parts are gonna kind of create a interesting outcome as well. So that's what I will do. Let me save or to flatten, then join them. Yeah, so you see, like, it kind of reacts in an interesting way as well. So this is the result that you will get. So I saw it's quite interesting, very unpredictable, depending on how you kind of use it. Why would you choose FET over sub-D multi-pipe? I am not using sub-D multi-pipe. I think I can also use sub-D multi-pipe. I'm worried it might be too heavy. I have not tried that before, actually. You can try, or maybe that will work. I hope that doesn't, it's not too heavy. Oh, great, it works too. Yeah, I think you can also use sub-D multi-pipe. It's just that I'm not so familiar at the moment with sub-D multi-pipe. So I've been using like flatten most of the time, but this works as well, works great. So that works too. So that's great. There's one more option then, I guess. So both works. Yeah, maybe I'll get the bifocals during the break. Okay, so that's the first one. So there's several patterns that you can generate with the same logic, and all of them which are pretty interesting. So the next one, I'm going to do a quad panel. So same thing, I'm gonna duplicate this whole thing. So for quad panel, let's try instead of having everything, instead of having sorry, instead of selecting, let's have everything integrated, and let's just see like how it will look like. Just turn this on. Let's check. Let's preview this. So let's merge the quad panels, the result of the quad panels. Right. So let's merge, or instead of listing the items, like two of them, let's just try like everything. So all four sides. And let's just see the how it looks like. So now you can see this is also getting pretty interesting. And you can see the effect. Yeah, so you get sort of like a different pattern that's generated and combine everything. But that kind of creates a like a different kind of pattern. And yeah, I think, are you guys following so far? Okay, great. Yeah, so like there's like, so what's interesting is, for me, what's interesting is that like with Lunchbox, even though like the results are really predictable, like in terms of like just taking a surface and you panel them to get the result, but when you actually combine them with the Crystallon merge curves, then all of a sudden the results get kind of unpredictable. Sort of like, I mean, it's not exactly a growth algorithm or anything like that, but it kind of makes it have the sense of something that's created in nature. So I thought that's pretty cool. Exactly. Yeah. Then let me see. What should I try next? Okay, let's try. This. Next, we have skewed quads. So same, so just duplicate that. Glad to hear it's very helpful. So I'll try two more options from here. You could just like, you know, take what you want to try and have the this kind of pattern tested. I think it gives a lot of different results, which is pretty cool. One second. Okay. So now we have two. So you can see this is asymmetrical, right? Looks very different. So the result that you're going to get is also going to be kind of asymmetrical. You can try how this looks like. I'm going to try to reduce the let me just check this real quick. So let's try to reduce this number. Instead of 50, let's just try 25. 25. So same thing. We just replace them. Now, I'm afraid it's a little bit takes a bit of time because I think these are very detailed. Oh, it looks like. So yeah, that's the result. Kind of mismatched. Kani is mismatched, so it looks like that. So you can also fix that. Just disable it. Doesn't take such a long time. Screen? Yeah, I'm muted now. Sorry, I was disconnected. Can you hear me now? Okay, great. Yeah, as I was saying, you can see that it's mismatched, right? But you can also fix that. It's because when the surface are created, the UV are not matching, especially because they are mirrored. So what we do is we gotta correct them. So I kind of find this side more interesting, so I'm gonna try to match this side. So I'll keep the second one, so I'll try to match the first one. So I will need to adjust the UV. So we might need to swap. Let me try swapping the UV. Helpful when you want to correct the UV. So swap UV doesn't seem to work. So oh, sorry, I need to connect that first. Yes. Right. So this is okay, this actually looks nice. We'll try to match it to this so it's not swap UV. So let's try a couple of stuff so you could. No, when you swap UV or you change the direction of the UV, you get a different result as well. Let me try real quick. Yeah, okay, so now it's matching, right? You see, so you gotta might have to try a couple of times. Another way is actually to show the UV. So this way, UV display. I'm not sure this, if you need a plugin. So you could see like the direction, and this should be mirrored in order for everything to match up. So you see now it's mirrored. Or this is like this direction is wrong, but I think it's still working, so that's fine. But this is helpful when you want to see whether it matches up. Then yeah, so this is what you get after mirroring. So you can see it's off like the and this see pattern. I don't know why it's always, I'm just curious. I don't know if it's the same for everyone, but every time custom preview starts off, the material color starts off with a hot pink. I have no idea why. So yeah, this looks, let's just check out. Yeah, so this works well. So yeah, I think there's a lot more you could experiment with in Lunchbox. So these panels, thank you. These panels you could just try on different ones. It gives you different effects. For me, I think diamond skewed, with skewed one you can even change the angle, and something like a staggered one is also very interesting. I think I have it as like my last example. I think, but in the essence of time I won't go through, but they're pretty much the same way of working them. And you can also get a different effect when you adjust the UV. So when you flip the UV or adjust that of the axis, and that will give you a different result as well. So that gives you like lots of options to play with, like so paneling like the direction, and selecting whether you want to select all the lines or you just select part of it. That gives you different kind of output, so that way you have so much combination you could play with. So yeah, I think like for Lunchbox and Crystallon, I think we are good here. So I think we could take another 10-minute break, and after this I would try on another wing, the upper wing. So instead of using something like that, I will use Parakeet to grow the pattern instead of using something like that, which is you kind of do sort of like a backwards engineering of it. Yeah, cool. Let's take a 10-minute break now. How would you fabricate something like this footwear? What kind of material could be used? For something of this geometry, like this wing design, you can actually fabricate it in 3D printing. But if you want it to be this intricate, then you won't be able to do it in FDM. You have to do a resin print. So like this company that I founded, Lifeform. So the idea is to create 3D printed footwear, and I am using resin 3D 3D printed resin. So that technology is able to kind of replicate that. So like if you were to imagine Adidas 4D, if you are familiar with that, like that 3D printed midsole, that material slash that technology is able to produce something like that. If not, something like a SLS system would be able to kind of fabricate that as well. But conventional way of producing it would be tricky unless you mold it. You could actually mold it as well. Mold it into a fabric, mold this pattern into a fabric as well. That could be possible too. Yeah, but just this geometry itself with no underlying base support material, you need to 3D print that, most likely. Yeah. What? When your question, to answer your question, you say when you select curves, do you select curves division randomly or specific ones? When you subdivide, sorry, not subdivide, sorry, when you using Lunchbox, sorry, Joa, I hope you are hearing. What happens is that just could you extract curve then do divide curve? Let me show you real quick. Joa, if you're around, so like basically, yeah, Joa, I can just answer your question right now. So yeah. So I can repeat. So basically, if you were to look at the screen share, these panels are all individual 4H, not really square, but they're like this 4H panel. So when you were to deconstruct it, you get the individual faces, you get the edges, but you imagine like if it's one panel, it will be divided into 4 edges, right? So that's what you're actually selecting. So they are divided into, these are divided into like 4 edges. So if you were to select 1, 2, 3, 4, 0, 1, sorry. Let me edit this. 4. So it just goes around. So 0, you see 0, 1, 2, 3, 0, 1, 2, 3. So basically it selects the same edge. Everything will select the same side of the edge. So that's what I'm selecting. So you don't actually have to do you don't have to do something additional. When you select, you just get that same selection already. So it's already arranged in that sense. So you could just, because they are branched together. So when you deconstruct the edges, they are kind of like branched together. So you just select them together. I hope that answers your question. You don't have to divide curves in order to get these. You can just select them simply after you deconstructed the VLAB. How do you approach on making the base design color of the shoe? Right. Wait. How do you approach making the base design curves for the shoe last from a particular inspiration? Well, I think you would need the shoe last itself in order to get the base of that shoe last, because it's a very specific like specific geometry that you need to follow. But what you can do is you could take your favorite shoes, and instead of the last, I think last is, unless you have the last, it's difficult. But what you can do is you could download last online as well. There are some like free last, I believe, available online. or the other thing you could do is to take like if you were to find photos of shoes that you like on the sole, you could kind of trace that and use that as well. But if you're talking about shoe last, then yeah, you need to find a way to download that online, or scan one if you have one physically, in order to get the right data, basically. But that's kind of like, there's a saying that with footwear designers, last come first. So you need to have that either digitally or physically and scan it. Yeah, because it needs to be of a very specific measurement in order to fit the foot. So it has a very specific shape and whatnot. Yeah, I hope that answers your question. So you need to kind of find something that you can work with. Great. What I really meant, sorry, Jawad, I'm trying to read your question. What I really meant is the very first beginning when joining the vertical curves. Sorry, Jawad, I don't exactly get your question. Yeah, Daniel, yeah, sorry, Jawad, I don't exactly your question. So vertical curves. Maybe I think I just used, I don't know if that answers your question. I think merge curves, because they are close enough, so I think they'll just collapse together. I hope that's the answer you're looking for. And also, Daniel, yes, I think you are right. Designers should be able to design last, but I think last kind of involves a lot on the anatomy of the foot, so I think it's a little bit more tricky. But I mean, if you have the data and you are familiar with designing a last, yet definitely you could design. Yeah. Ah, okay. Wait, I think you could actually take the design. Other way, you can actually take some of the shoes that you like. If you see where the midsole and the line between the midsole and the upper, that line you could actually just trace it and follow it. It should fit quite all right. I think as an approximation, if you don't actually have a last to get the exact curve. If you go to the first formula on Grasshopper, this one, okay, and you see the curves assigned to the, okay, okay. Could I just extract curve then do divide curve? Okay, I think I understand you now. These two, right? Yeah, you can actually divide them. You can actually take the whole loop. You can actually take the whole loop of the curves, then you could divide the curves. I mean, you are right, you could do that, but with dividing, it's a little bit more tricky. I did thought of doing that, but there's a sharp edge, so you need to be able to assign the position really accurately. Or if you want it to be because there's a sharp edge, right? Imagine when you divide curve, your points are like maybe here and here and here and here, and you have two sharp edges here, and your result might get a bit funky. But technically you can do that. Yeah, technically you can do that. If that answers your question. All right. Okay. So let's continue. Sip of water. Next part we'll be looking at. Next part we'll be looking at. Quick. Okay, we'll be looking at parakeet growth. All right. Java, I think like what's the rule of the time? I think you could just, I think it's easier to extract the curves than to try to divide curve. I think you get a better result in this case. Yeah, because it's very specific where the edge of the curve should be positioned. If there's no specific position, if it's like an oval shape or more circular shape, you can actually divide equally and you could get a different result as you shift the position of the division of the curve. Yeah, but in this case, it will help more. But if it's a rounder shape with no like pointed ends of the curve, that the continuity is like smoother like a sorry, I forgot what is that called, R2 or R3 continuity, then I think that's fine. Okay, moving on. So now we'll be trying out. So these are like a little bit, I would call like pseudo like growth kind of look, but now we'll try to do something that's like literally growth. So let me go to this Parakeet plugin. So Parakeet is a plugin that allows for pattern creation. It has a lot, and there's so many that I myself haven't, had the chance to use everything or even try everything yet. So and it recently had an update, and it has a lot more options. But for today, like the topic of the design, we will be looking at under pattern generation here, Parakeet. So this is Parakeet if you're not on that. So we'll look at growth. So growth on VWeb growth mesh. And then we have venation and venation tool. So growth on VWeb or growth in general is I believe it's called differential growth as well. Yeah, it's also known as differential growth. It's something that you might find on a brain coral, the way that the shape is being packed. And then venation is something much similarly to like a network of branches, which is what you would find in leaves. So these two are really the idea is based off of nature itself. So let's start with the first one. So growth on BRAP. So there's two, right? Maybe let's turn on. Let's just open two. Just do a quick comparison. So I believe growth on mesh is just recently added, and it's really a helpful addition. So it's also very interesting as well. So let's try that with our other thing. So if you were to open the top thing, yeah. Okay, so let's just set that inside. So with this, I will join. So because like, okay, let's just quickly see the input of what is needed. So if you see growth on growth on BWeb, we want this growth to be entirely continuous throughout the whole fin. So we don't want to have a discontinuous one. So it's good to kind of have them joined up into one piece. Where is this curve? Oh yeah, sorry. I think I selected curve by mistake as well. Just select this two again. Your values. Okay, looks fine now. Let's just set one on. Okay. Okay, so first input is BWeb. Then you have distance, maximum possible distance between the pattern vertices. So basically, it's that this is gonna create something that's like a coral, right? So there's gonna be space in between the lines, so as to avoid collision. So I think that's the maximum distance, possible distance, I believe. So let's just do 5 first. Sorry. So mode is basically where the growth starts. So like at a particular point. So let's in a while you see. So minimum point count and maximum point count. Minimum point count is basically the count that you will see at the start. So like it starts with like say if you put 20, you'll start with 20, and the maximum is say 1,000 and 1,500. So you will go to a maximum of 1,500 if it's not completely yet. And reset is and this is a simulation, so you will toggle Boolean toggle it. So when you click false, you will not reset. If you keep true, you will reset, right? This simulation. And you need something else called the trigger. So how this works is you can actually create this exact thing. This is like a concept, but you can also recreate this on using an anemone loop. So how this works is that it works trigger means you set this function to work. So how this works is it works on iteration on itself. So you do the, for example, you start with a generation 1 and you iterate and becomes the second iteration of this. You take the second iteration to create the third iteration. So that's why it needs a trigger to continuously feed it, means continuously, make it loop basically. So now you can see when I click through, you can see like this is where it starts from. So let me just set this interval to, because it needs to continuously like loop in order for it to work. So you said I set like the 20 millisecond for it to keep looping on itself. So you have this, you could start from here, then you have this mode, right? Let's say 3. There is how many modes? There's 0, 1, and 2. So if you click 0, so like it gives you different result the mode that you are using, because like it starts with a different position and even different size of where this goes. And select one, then it starts here, then you select select two, and it starts here instead. Right, so let's just try one. Let's just try one. So in order to start this, instead of reset true, you should reset should not be true. So reset is false, so you don't reset. Then after that, you click trigger. So you can see this growing. The name, Jawad, the name of the plugin is Parakeet, like the bird Parakeet. Yep. Yeah, this is it's pretty cool. Yeah, so you get something like that. So it's still growing. So I think when you change the distance, that will actually give you a different result, because like the distance is kind of like between these two. Wait, sorry, I might be wrong. Yeah, so that's that. And let's try with a different distance. Let's just say the growth pattern is completely random, or can we control it? You can control certain aspects of it, but when it starts growing, it's up to how it kind of grows. So what you can control is the position where it starts to grow from. So that's with the mode and the density of the points. So if you have it less dense, it could end prematurely. Like for example, it grows and it run out of points to grow, maybe it'll just stops here and there'll be nothing here. Yeah, so that's what you can control mainly, is where it starts from. I would say, yeah. So let's just try a different distance. So this is 20. So let's reset that, set it to false, and play it. So if you see the distance is wider, longer, I think the individual, so I can't remember exactly if it's the individual lines or it's the space between them, but when you increase the distance, you can see that the pattern gets less dense. And let's try, let's say a smaller distance between, let's just say 5. It's gonna take more time, but it's just cool to kind of see it grow. Oops. Yeah, you gotta toggle that to false so it doesn't keep resetting. Yeah, kangaroo. Yeah, that's what I was saying earlier. So kangaroo in combination with anemone would be able to do this. Yeah, this pattern I really like. So I actually used that for one of my designs, which I named like Coral Runner, because like they really resemble or it's basically the same logic of how like the brain coral is like how it grows in this pattern. So yeah. Yeah, I think it's getting super dense and it's growing really slowly, but eventually you'll, really is really too slow. Just try a number a little bit bigger. Say 7. Okay, I'm gonna try to set up for. So same thing, you can fatten this. And then you can Weaverbird this. Okay, I think I'll just pause. You just pause this. Let's finish. So that can get really, really good if you reduce the distance by the place that you don't need to wait a really long time. Or maybe that I think my computer is kind of a bit slow because I'm like sharing screen at the same time. Okay, so when you think it's ready, you pause it. You can take this pattern and you can pattern it. So there you go. So you have this, around it. Yeah. So this is kind of straightforward. Then I'll just do the other plugin, which is the same. Which is this, sorry, not the same, but really similar one, but somewhat different. So what this is using growth on mesh. So next time, please get a robust PC when giving a class, please. Yeah, sure. I'm trying to, but I think like it's more of, I think the sharing of screen that's taking the RAM up. I think that's why it slows things down. Anyway, so growth on mesh. With mesh, you will need a input of mesh. So what I usually would do is to do a try mesh. And so you can adjust, like there's a lot of like parameters, but maybe the one I want to focus on is more on length. So that's based on how long these individual faces are, the edge of the faces are. So I think this is fine, which is like triangulation is a mesh itself. So let's use that. Distance is the same. Maybe let's use faster, like 10 mode is the same. There's one key difference here that I think is really interesting. Minimum points is also 20. We got here, same thing. Then okay, so what's interesting about this that it doesn't have for this function that was go from VWeb previously that was the only one that they have, and they included this one as an update. So what is cool about this is you can start face index, so you can select where you want to start. So with this, just now when we try to select, it just sets a position either here, or wherever. But what's cool about this is that you can select exactly where you want to start. So maybe you want to start here, or different. So what I explode mesh. So you take this, you explode it, and then you can list item. Oh, that's all. That's fine. I think because this is supposed to be two geometry, two sets of wings, right? But when I try to remesh use after the geometry is joined, it doesn't work. But that's fine. Let's try well and mesh. Well and join and well. And that should create a single mesh instead of having two. So that's why I select two, which is not what we want. Let's select this, and then okay, now we just select one. So you see so there are how many faces? Let's check. There's 524 faces. Let's just say 500 index. So you can see when I select 500, it starts from there. Then you could actually pick, say, I want it to start near, but I mean, it's a little bit difficult to click, but let's just say you want it to start near the edge. Sorry, near the pointed edge. So you could list this as an item and start face index. So it just wants the index, right? So you already have the mesh export, so you don't need to insert the mesh, but you could use this to locate the face that you want to use, and you take this index and you plug it here. And when you see the mode, yeah, so if you see the mode, 2 is over here, and since you click the start mesh there, see, what's it, 0? Yeah, if you were to select 0, this mode will let you select exactly where you want the starting point to be. So that's here. So for example, you shift it somewhere else, right? So it will move accordingly. Yeah, you can use that. This is really helpful because this is the most important thing. This is maybe one of the few things you could control other than the distance and all, is where the growth actually starts. So by selecting that, you get actually more control of where your growth happens. So for example, I select here, so it literally starts growing from this position. I used closest point component to select the face I wanted using the center of the mesh face. Yeah, that could work too. That could work too. So I just use this as an alternative that works too. So yeah, so you could select based on that. So if you were to see this pattern, would be different from something that you select. So let's see. Let's just try one more real quick before we move on. Oops. Yeah, okay, let's just start from here and let it grow. So instead of starting from the center, you start from this edge, and this basically just gives you a like complete different result. Yeah, you can see it's quite different. So that's what you can control. After this, okay. So yeah, so basically, wait a little bit more. And then you pause it once it's done, and put that. So you get this as well. So that's what you get, and you can further smooth that using different subdivision methods from Weaverbird. So you could have like different effect when you subdivide it differently. Okay. Okay. Yeah. There is, so you can do that. Okay. So I'm using constant chords, right? So you could try something like cat move sub. That should, in theory, give you a smoother line. So let me make this a bit fatter. So see better. Okay, let me just. Matthew, do you want to smooth the lines as curves? You could either exactly you could divide the curve and interpolate the curves of the pattern. Okay, let's just try that real quick. So let's do control. Let's get the control points. And then let's do a NURBS. You can do an interpolate or NURBS curve. So you will get this kind of much smoother curves. Then you can use a pipe. This should work to not sure why that is. But I believe it's because the use of NURBS curve. I think I have this issue before previously. So yeah, I think what I did was to fillet the curves. So what I did was to fillet the curves. Yeah, you can rebuild curves, or you're right, exactly. There's like couple of ways to do it. Exactly. Yeah, so I think when I used NURBS curve, it didn't work. So now I'm trying fillet. You could, yeah, there's a bunch of ways you could do. You could rebuild curves or fit curves smoothly. Or what I'm trying here is to do something that's also simple, which is just to fillet the curve, so you could get this result into like a smoother curve as well. So you could either work on the curves itself, or you could fatten it. Then after that, you do a CAD subdivision. Then that will give you also a smoother geometry after that. Hope that answers your question. So there's a few ways you could do it. Yeah, no problem. So degree, maybe 2. Yeah, if you rebuild and put a degree 2, you get like a pretty smooth curve. Yep. So on this ventilation points, root indices, and branch count. So basically ventilation, okay, basically what ventilation is, as I explained earlier, is actually if you were to imagine a leaf, it's like you see the veins of the leaves, it's sort of like a network of curves. So this is what that is. This is what this is as well. So remember, we have this mesh. we get construct mesh. So we need input data, right? Because it's not asking for like surface mesh or lines, curves, it's asking for points. So the way we can do it, since we already have a mesh existing, we just take the points from the mesh. So what is yeah, because we don't need that in the branch. Root indices. Basically what that means is that your network has to grow from somewhere, right? So like the indices is like the index of the where you think the root will be. So basically we could just so there's 324. So I think you could select anywhere between 0 to 323, right? So let's just choose, let's do panel. Let's do 0, 100, 200. Oops. Branch count is like every branch, like maximum number it can be on that particular branch. So it's 3. So cutoff distance, it's for example, how far maximum distance that each point can explore to create a new branch. So if it extends beyond a certain length, it doesn't grow a new branch anymore. So iterations, I'll just usually set it as T4. I am not sure why the root indices is not working. So I think maybe this doesn't work. So let me just try the regular 0. Just try. It's odd. Sorry, let me just check real quick. Yeah, I think the reason why this is happening is because the points is not dense enough. So let me try something else. Retriangulate. Okay, so let's just try, instead of retriangulating, let's try under vectors. You can populate geometry. So we just take the joint B web and we get points. So let's just increase the points to say 1000. Let's see if that's gonna work. Let me just copy what I have previously. Use this. This is what was working previously. It's just that the okay, there we go. I am not exactly sure. Let me check the trend. I think it might be because like the count is too low here. That's why it doesn't. It's not working. Let's see how many pixels. It's 1000 as well. Anyway, I think maybe I can try to save time. But basically this works. I'm not sure why that doesn't work. I think maybe it's the count number. But anyway, so what I did was to take the geometry that's already joined, as you can see here. Then what we did next was to do a remesh into of 5, distance of 5, length of 5. Then deconstructed the mesh because you needed the points as an input, so use that as a validation point. Then you could select the index of the point. So there's like how many vertices? So there's like around 1,000 vertices. So you could select based on that. So like this number is really big, but it's just basically repeating itself. After it ends at like 1070, it will just continue from 0 and select. So it doesn't really matter. So I selected 3, but you can select any number of points. So let's just say if you only wanted one indecent, one number, you could also do that. So let it run. So basically what it does is if you only select one, it's just item. Index is, so it starts growing from here. So you can see like this is the starting point of the growth, and it grows all over. So it's all connected from this sort of like root and grows. And then we have like 3 of them together. So if you were to use the items. So you can see like there's 3 kind of start off where things grow. And then of course they connect. You see, so you could see 3 distinct growth patterns. So you could almost see a line across here. Yeah, so this is what that creates. So when you change the branch count, say 5, so it kind of creates like branch with like the maximum they can have like 5 different branch from one node. And if also the cutoff distance, so if you were to put, let's say 3, so 3 doesn't work, let's say 10. Yeah, it gets super messy and overlaps because like it's allowed to grow for too far distance, but maybe there's something you want to create, so that's fine as well. But let's just keep it at 8 for now. So this is the first style of animation. Let's try the second one with the same input. It's a different I think the backend of the coding is different, so like that pattern itself is different. So points base match, so same, let's do the same point. Okay, so what this requires is the base mesh. This doesn't. So I believe this follows the uses the point as part of the input, and root points, same thing. Okay. Right, so the root points is different from this as well. This takes the root indices and this takes the root point itself. So you need to use the point itself as a input instead of just the index. Yeah. So yeah, so you can clearly see that this pattern is really different. So I mean, there's like cutoff distance and step size. I believe this is also iterative. So step size is more of this individual growth of the curve, how much it grows. So it's a step of 0.25, sorry, 0.2 by 0.2. And this cutoff distance is the same as previous one. So you could see like, so they have a very different kind of look to them. So this is the first one. Let me just make it real quick. Sorry, this is the second one. So, sorry, first one. Turn this off. So yeah, this is the second one. This is the first one. So you can see like the basis of it is very different. So they grow very differently. I guess it's up to, I think, your preference on how to use them. So I think that's for variation. You can also same thing, you can fatten them. Okay, I'll show it for one. So I'll show it for this one. So let's try for a second. But basically almost the same input. So using the second one, so what else we can do is we can do a flatten. Sorry, give me a minute. I think it's quite a heavy. Ankit, manipulate the infill for printing with these tools. I think if you are talking about FDM, I think they might be too thin. But if you are talking about the shoe itself with like the whole volume, I think you could do that. I mean, if the pattern is kind of merged with the whole of the shoe, I think you can actually print the whole thing like using uh with FDM, and therefore you can adjust with info. I think there might be an overload. So maybe we could take another break, and I can continue this afterwards. Yeah, Daniel, the pattern is growing outside the surface in some points. What can be done? Okay, let me just let's go for 10 break. Daniel, the pattern is growing outside the curve in some points. What can be done? Okay, so in this case, if the pattern is going outside the surface, I think sometimes it does. Usually when you usually when you do a review of the curve, it usually comes back in. It usually is rounded, so because it's sharp, you will kind of get back into the surface. But another way of fixing this is taking the points and using I would say closest BREP, closest point on BREP. Closest point on BREP would kind of bring that point back to would plot all the points back on that surface. I hope that answers your question. Can you fill a cube with texture? Sure. Wait, can you fill a cube with texture? Yes, depending on which one you're talking about. If you are talking about using the Venetian, because it's using just points, it just depends on your input. If your input is a surface like the paneling, like the Lunchbox, then you can't really create a surface create a surface using create only one surface of a cube, but you can do for these ventilation points because you can plot the points on all sides of the cube. So it's something that you can do. Ah, can you fill a cube with inside the cube? This is adhering to. Yes, I think it's possible. You know what? You can try that real quick. Yeah, we can go for a quick break while I just try this real quick. Yeah, and Kit, I think the second one you can't really do that because you need a base mesh, so you cannot fill a volume with just the mesh itself. But it seems like the first one you could potentially do. Let me just try it real quick. The rest you can actually go for a break. So let me just populate this. Mine is starting to work. Yeah. And Kit, yeah, it works as you can see. Good suggestion. I didn't actually think of that, but yeah, it works. There you go. Let me just restart my Rhino again. Let me share screen. Okay. Let's continue. Yeah, we were at the key. Let me just try to show you one more thing about this animation. Yeah, just now I think the reason why like it crashed is because my cutoff distance is really too small and the step size is really too small. And in the end, it creates such a huge number of curves, lines, collection that it makes the whole thing slow down. So sometimes that can be tricky. So let me just try to do that real quick. Deconstruct mesh. Just do one. Track. Apologies for the delay. Just check. Okay, so right with this, we have this pattern out, right? So then we do a pattern. And we have this kind of shape. It's not so interesting. N-type. Yeah, because it all looks very uniform. And it's not so interesting. So what we can do is to do a variable thickness. So previously we have not tried this before, but if you look at this thickness, there's spheres, so it can set the radii of the node at the center of each sphere. So basically, I believe this is the node. So this input is basically spheres. So you can also have a variable size kind of veins, I would say. So what I would do is to get this distance, let's just say the root. Let's just say the root is the thickest. So this part will be the thickest and the rest will become thinner as it gets further away. So let's try closest. Closest point. So the point to search from, this is the cloud, and the point to search. Oops, not this, the point. Yeah. Okay, because we are only using one point, we don't actually need that. So we can just find the, let's create a, we can create a 2.9. So endpoint, and so we're gonna have 1031. So these are all lines that measure from here. Let's do distance. Curve length. We can use this information as the point of reference for creating a thicker to like thinner line. So when we get this line, we get this length, we'll have to remap that, because like the length is like from, sorry, be from 0 to 266. If you put a radius of 266 for the spheres, it's going to be crazy big. So we're going to try to remap that. So remap numbers to create something that's more manageable. So domain is the source, the value is the length, and the target is we need to construct a So now, if you were to measure the distance, I believe you guys can hear me, right? So you just type in the chat if you cannot hear me. Okay, I'll just continue. So you want the closest to the point is the point itself, so that distance is 0, and the furthest is here. You want here to be the thickest. We want here to be the thickest because it's the root, and the furthest part to be the thinnest. Right, but now the distance wise is that from here to the furthest part is the highest. So if you were to map the domain from for example, you want 0.1 to say 2. If you map it this way, then this will be biggest and this will be smallest, but we don't want that. We want here to be biggest and here to be smallest. That's why we're gonna flip the domain like that, instead of like the other way around, from big to small instead of small to big. So this is your target. So this is your map numbers, and you need sphere. So the thing with the spheres is that you're gonna create a lot, and if you're gonna do the preview, it's gonna make the whole thing. If you're gonna preview, it's gonna make it really slow. So what I've learned is to just turn off preview. The map number would go to the radius, and the base would be the vertices. And then you're gonna use. So the reason why if it's so still everything looks the same, because okay, so now you see here it's getting big, but here I put 0.1. We map to 0.1, but here is still pretty big. So like the reason why is because like the usual thickness is 1. So I think if you want it to be small, so this number, the thickness should be, the smallest thickness should be the same as this. If not, this will override and become the minimum thickness. So let's try this. So there you go. So if you were to see like based on the distance, this will be the smallest, and whatever is, but this looks a bit odd. Yeah. So I think the reason why that one is odd is because the nodes are not adjust in a specific manner. So if you were to do this, I think it's gonna clean up and arrange everything so that it can be a reference to this, because the spheres are not exactly matched up. So we need a sort of like a reference point. So that's why you use the nodes. So let me just disable this first. Let's use the nodes. Yeah. So now after doing this, so using the nodes as a reference, using clean network, you can input that as the base of the spheres, and then you add the radius. That will kind of clean it up, and then you get a, like a gradation of thickness, so from thick to thin. So if you want to have like a variable thickness depending on the where the root point is, or anywhere you want, you can actually do this. Then next is let me just check. So I think there's one more part where I actually connected where I try to join both the growth on mesh with the this ventilation pattern. I think we are a bit short of running time. So like if there's been more time later, I'll go through that. So I'll just jump on to the next one first. So the next one is actually using Pufferfish. So the next part is Pufferfish. So let me check that. Okay, give me a second now. Let me just check that real quick. I didn't forget. For the next part, will be looking at pufferfish. So, okay, this one I'll hide. Okay, so the input we'll use is this for the sole. So basically, because I only wanted the sole part, so what I did was to take the inner side of the shoe and extracted this B wrap sub D, sorry, sub D. So this is what I'll be using as the base. So I think this is something really simple. So you just have to extract it out, and this is what you are left with. And I also created this 1, 2, 3, 4 surfaces that would be used to create a twin surface that will kind of extract curves from these lines and create sort of like a profile that you can a loft profile that you can use for pufferfish. So let me just show you. Pufferfish. So pufferfish is also really powerful. It has lots of function with like twinning and and also twisted box. So what we'll be using today is actually twinning surfaces and using that to create a loft, and using that loft surface to create twisted box. Okay, sounds a bit like complicated, but let me just try. So twin consecutive surfaces. Both will work. Just try these. So because we are trying to twin consecutive surfaces, so I believe it helps when you want to select multiple. Set multiple. So it's good for you to select one by one. 1, 2, 3, 4. I believe it helps with the because it needs to be consecutive. So when you click on it, you arrange them accordingly in this manner. So then you have like the in between. So when you tween it kind of twins and adds the same surface in between them. So factor is 0.5. So use range. So when you add the range, what happens is that instead of having factor is 0.5, so you need have in between 0.5 is half, so you need have 1, so one of them added. But when you add the range is 3, so, you add a range and you divide it into 3 steps, you actually get 2 more here. So you could just increase it however you want to. If you want to increase the accuracy, basically. So that's what you have, and then find intersection with that. So this should be. Yeah. So basically, you will need to find curves in order to create the loft, right? So in order to do that, you need the base geometry that's intersecting with these surfaces. These are planar surfaces. So you get these curves. So what I will do is also remove duplicate curves. Sorry, sort duplicate curves. Yeah. Just to be sure there's no duplicates. Then using these unique curves, you want to create a loft. So this loft is looking a little bit funky because I believe the points are different. So I'm going to try to rebuild the curves. Degrees. Okay, so now you see that this is quite a close approximation of what we had just now. So this itself is already a surface. So that's how you kind of create like the base of the part you want to loft using pufferfish, but that's not all. What we really want to do is that we want to create like the point of doing this is that like the bottom part, remember like we had sort of like the fin patterns on the top. Then for the bottom of the sole, I wanted to create a like skeletal, like rib cage kind of pattern or shape. So I think like pufferfish is great because remember what we had before. We are using sort of like a paneling kind of sequence and creating a pattern out of it. But what we can choose to input is not up to us, because like if you see, we are using Lunchbox, so they have a set of components that you can use. So you are kind of like fixed to that certain range of components that you can use within. So you don't have the freedom of like creating something something that you want to custom, but with kind of like pufferfish using twister box, you can actually have that. So let's just do a really simple one, twister box surface. So in this surface, you see you could start to have something, but I mean, this is really low. Let me do range again. So the same thing, you divide the range, then that will give you the number of like twisted box. So these are called twisted box. So essentially what they are, like units of reference points, and when you create your own geometry, you can then manipulate them into all these boxes, and that kind of gives you a similar way as paneling with Lunchbox, but Lunchbox wise, you only can have like quad, or like diamond shape, or that kind of simple shape. But with this, you can have more customization. So let's just do a step. So that determines how many twister box there are. So thickness, you can just do 6. So now it becomes thicker. So 11. So as you increase the range, the accuracy of the twister box get closer to your original geometry. Then W wise, I only need one layer, so I just added 1. So the part where it gets complicated would be so more dense would be these 11. Yeah, it's all right. So now I think the fun part is this twister box. Sorry, it's transform. So you wanna morph to twister box. So you have a geometry and you want to morph it. So basically, let's take the pufferfish. So I already created some really simple ones. So these are nothing more than what I showed you. These are like subdivisions. So these are nothing more than what I showed you earlier, using subdivision to create these shapes. So if you can make it real simple. I delete. So basically, it's literally just extrude here, extrude here, and get the gist. So it's actually really simple. So what we do is that let's import 1. So that's the first pattern. the pattern. So you could actually manipulate it as you put it in. So while it's in the twister box. So what I can do is, so reference and okay, so basically target is the target twister box. So you want to do this. Geometry is this pattern. All right, before we do that, let's convert the, I would prefer to convert this pattern into a mesh. I'll do simple, just because mesh in general is lighter than NURBS. So, and reference is basically how in relation, how is it going to map this into the twisted box. So if you were to put the original geometry, it's gonna do a bounding. So it's an equivalent to having a bounding box. So this is the bounding box. So this reference is what they need is this bounding box. So that means that this box will occupy this individual twisted box. So I'll show you the difference when you try to manipulate this reference box afterwards. So if you were to put this in, you see that you've usually successfully manipulated and kind of use that for the twisted box. So you can have this geometry and twisted box. So you want to do a Weaverbird, you want to join and weld. Then you want to do then you want to expose mesh, because I believe there's holes on the top because of this here. But the reason for the holes here is so that, you know, when it connects vertically, it's able to weld as mesh, so that, you know, you don't get individual separate kind of mesh. You get like connected ones. So let's do this. Close mesh. Then subdivision. So you get something like that. So what's fun is that you can actually do this while on the fly. So what you can do is select the shape, and that will reflect in the twister box. But oops. Yeah, if you do it. Yeah, so that's the first pattern. Then let's try. So these patterns are really simple. So you can actually make it more complicated if you want to. Okay, sorry, Jawad, you were saying you wanted to see the range. This one, right? Okay, so basically what the range does, sorry, there's, yeah, you're good. So basically the range is what is going to determine how many twins, number of surface are sandwiched in between the three of them, three of the surfaces. So this number will determine how many sandwich. Okay. Moving forward. So yeah, so saying you can try another pattern. So I just made a couple, so you can just make a few on your own. So one thing to take note of, if you want something that connects and you know, connects into one piece of mesh, what you need to do is to leave holes here, like both ends, so that they align and you can weld them, join and weld them at the end. And let's try something like that. So let's try another pattern. So this gives you a different, you can see different patterns here. And the other thing that I wanted to kind of explain to you about, just try one more and I'll explain to you. So previously you see that that's the way of doing things. So with the third one, so these two, like, is shaped with volume. The base volume is more like a surface without volume. So you can also do this. So it gives you a lot of freedom to kind of create the shape that you want. So you could use you could use this shape. Just turn this off. So you get sort of like a flat surface, like basically made out of surface. So you want to kind of create volume with this. So you could do Weaverbird, you could thicken it. I just say 2. And then we can subdivide it to make it smooth. So you get like different kind of, you can manipulate different shapes in order to give you this. You could use actual geometry or the base unit of the pattern with a volume. You just have to leave holes at the end so that they join up together. Or you can choose not to, that will work. So you have like individual separate units. And you join them and you get a volume. And you can also use something that's more like a surface. You join them and then you thicken them to create a slight different effect. And then finally, this. This is what I use in the end. So you can see here. Exactly. Exactly. You need the UV surface flow of the surface. Sub D do not provide that. So with sub D, the tricky thing is to kind of align the exactly what Michael said. You need to align how they are arranged. So you kind of need to align them in this manner how they are arranged. With sub D, they don't have a organization of how they are arranged. So in the end, I think I did try before. You can actually convert them into mesh and extrude. But you can do a twisted mesh, but things are not going to be aligned. You're going to have like these individual units in different angles sometimes, and they don't work so well. So that's why you need the surface, because it's kind of like having an order to the arrangement. Yeah. So the next part I want to do is want to explain is that you see the reference of the references, right? So like we've been using the same reference so far, but I wanted to show you something a bit different. So let me just hide this. So this is the base I'm trying to use. So let's just set this as pattern for set one geometry. All right, so everything connect. Well, sort of, they don't connect, but they are, like they are evenly spaced. But what if it happens that I want something? So for example, I wanted to create a rib-like structure, right? But I don't want, rib has kind of like space in between, like here. But it seems like they are pretty tight, even though they are not joined together. They are very, very tight, and I think that doesn't work so well for the design. So I wanted some space in between. So how can I manipulate that to get more space out of them? So what I will do is actually, I will use this instead as the reference geometry. So with this, I'll use this as the reference. So imagine now it doesn't fit into a box, but at the end, see, I still kept it to the edge so that they still join, but from side to side, they'll have a bigger space. So see, so that way I can, if you were to manipulate the space, say you want even bigger kind of space between them. If you were to increase this space, you get even more space, and if essentially you are squashing this in itself, so you get more space in between them. So yeah, so that's kind of like how you can use Pufferfish. And let me see what else. Yeah, and what's also fun about this, about Pufferfish, is another function about it is because this kind of looks a little bit like I said, like a little bit predictive in that sense, because like the gaps are kind of like all so even and all. So we can use something called a pinch and spread from Pufferfish to kind of create a something that the surface, to create sort of like unevenness in the surface in the UV, in the UV distribution. Then the result that you will use as the twisted box will get different as well. So let me just show you. It's easier to show you. So and spread. So what I will do with pinch and spread is that it needs points, locations of where to pinch and spread, points, radius, strengths, and anchors. So first we need to go to the surface. So loft is our surface. So we need to, how do we get points from surface? Same thing as we did before. divide surface. Oh, and stuff. So let's just say location of the points. Just pattern them, and let's just say how many points are there, like 651. Maybe let's choose 3 different numbers. Radius, let's do the let's create minus 1.0. Minus 10. Oh, okay, yeah, I just did a little setting wrongly. So this point should be here. So that's the points to pinch and spread. Location is where the points, the location of where to pinch and spread. So let's do point. Sorry, list. So these are the points. These are the index. So these are the location of the points. So there we go. So let me just hide this first. So let me see this. Yes, so these are the parts where we pinch and spread. If it's not, it's enough. Let me just try with a bigger radius. Yeah, you can see now. Like if it's positive, it's attracting, and negative is repelling. So that kind of, creates like some differences. So let's just say something like that. But you see, like the points are kind of getting off track. So we need to bring it back to where the surface is. Not these are, going a bit off. So what I will do is surface closest point. So these are the points, and the surface is the north we created, so that it doesn't go off. Like here, you see it's going off the surface. So we're trying to bring it back. Just make sure it's back. So we have that, and then so next we need to construct the surface. So surface from points. So this is the point. UV count, remember we need to do an addition of yeah, this looks funky, right? It's because we need an anchor for this edge. Because these are moving, that's causing this problem. So they need to be anchored down, and there's a function for anchor. Surface from point. See here, they will not be affected. So what we need is the edge of the B red. So we can construct to get the edge. Or we can't do that. Let me just take this. So you get these. So you get the edge curve, right? And let's try to find out what is the. So these are the points that are not supposed to be moving, right? But they moved, so that's why it's creating this weird gap in between the surface. So what we need to do is make sure these are the anchor points so that they never move. So what we need to do is this edge, we can extract the curve. Let's see if this works. Then we get the control points. This. Yeah, this is not working. Reason being because these points are not well kind of defined, and also because it's not in the list of these pinch and spread. Sorry, not in the list of these. So it's different points, so it doesn't match. So we need to make it match. So the way we could do it is to first surface from points. So we recreate this with no distortion. Then we extract this curve. Then you get all the points. Because this and this has the same number of points, because you're creating this surface from this point. So the edge will match perfectly. So the points matches perfectly. See? So therefore your surface is good. So it matches as per our loft surface. So yeah, so it matches pretty much the same. So you can use this as an input surface after we manipulated it. Add this surface. So yeah, so basically we just add this here. Let's just try to manipulate this and see if we can get it more obvious. See, it's starting to move a little bit, especially this part. You see, let's make it real small. Yeah, it seems like it's not moving, right? But if you see this is okay, let's just, if the radius is really small, it's not really affecting, it's not really moving, but when you get the radius really big, see, it starts to manipulate the shape and it gives it a bit of unpredictedness. And that's what makes this interesting. So you could try the strength. So that goes really crazy. That's why. So you can see this being distorted a lot. And not so much. Let's maybe try positive and see what that. So this is minus 0.8. So that repels, and when you bring this down, kind of attracts this point. So it becomes kind of funky. And I mean, we could kind of make things more interesting as well for the design. Yeah, so there you go with this. Oh yeah, custom preview, absolutely. My bad. You want custom preview in pink, hot pink? So you can see the shape being manipulated. So let's just see again. If you manipulate the numbers, let's just say this is just one. So without moving the points, then you increase the influence of the radius. So I think that it kind of affects everything within a 30 mm radius, I think. So there you go. So you get small. Then also you could try with like the position of the points. Yeah, so it's here and it's here. So you can see what works better for your design. I just of course, you can pick a specific point, closest point that you want to. But I'm just doing this because I'm not decided on which point I want. So I do this so I can kind of visualize the effect, and kind of when I find the right spot, that's where I stop. So I think just toggling it. It's also easy. So maybe something like that. 60. Yeah, something like that is interesting. Yeah. Yeah, and one more thing I did was so using this, let's just try one more pattern. One last pattern. So remember Crystallon that we're using. So we can try using something that's from, so they have a set of things you can choose as well. So it's kind of like a flexible system where you can choose whatever you want to kind of add in. So let me just find this selector and cell type. So you can choose. Basically, there's a lot of different ones, but I'm going to choose gyroid shell. Unit cell is this. You can actually preview the unit cell from so small. I'm not sure if you're familiar with gyroid, but gyroid is basically this structure. Maybe it's easier for me if I kind of just apply it. So with gyroid, I'm going to use direct reference. So oops, this will be a mesh, so you don't need to do that. So this is gyroid. So distance might be a little bit too much. One, so it kind of creates it's a kind of interesting shape, but like what I wanted to do with this is not this, but twist the box more. Okay, I'm not doing too well. So you're getting this kind of funky shapes. So what I'm doing is actually to so many yeah, okay. Edge. and reduce the amount of a twisted box. We say 20. And so naked edges. So now you see these are all edges. So what is also fun is that you can create a shape using sub D, a simple one, and then instead of using the full thing, you could actually just extract the edges, and then you do a pattern. No. And same thing with the subdivision. Small. And you have sort of like this kind of odd looking cage. So that's that, right? So maybe if you take that in. Maybe another option, or you can even merge them together. I think there's more interior flows. It's kind of, yeah, this starts to look really like odd and somewhat interesting. So that's something you can also play with. So you don't have to just take the edge, the mesh itself of the base unit. You can actually extract the lines. If you create from sub D, you can always extract that. So yeah, so let me see if I have anything else. Maybe that should be more or less it. Yeah, I think that should be more or less it for this. I've rendering, so maybe I can just show you guys real quick. So shall we do the like a render in KeyShot? Are you guys also using KeyShot? Great. So let me just turn this off. So I think KeyShot is maybe something that can be quite simple. So same thing. So completed model. So let's just use this. So you know, like, so the same thing. Like, just maybe quickly explain how I make this. So like the fins you already know. So it's just a subdivision. I kind of stick it to make this pattern. And then for this as well, I kind of extracted the sub D, and using the same method, you could check in the you can check in the sub D for a layer. Actually, you also have the curve, so you know where I actually where I actually create the curves at. So it's just the edge mainly. Then for the fin, I have two kinds of like skeleton kind of looks. So there's this one and oops, this one and this one. That was the original one I created. I quite like that. So maybe you can just use this. So yeah, if you see from the inside, you can also see this kind of like skeleton kind of shape, which reminds me of, you know, like the transparent sea animal. So with that, let's just do. Okay, let me share this. Let me change the screen. Um, so yeah, I just import it really quickly. So this, because like you can see like clearly it's like into the ground. So I just snap the ground. That's good. So lighting wise, I have like a preset myself. Usually that's what I do. So shadow 5, I have shadow, then 15 ray bounces with 15 global illumination in product mode. So I kind of have some preset materials, but they are very, very simple. So this is just glass, like purple glass. So with rendering, I think what's important, most important is the lighting. So for lighting, usually I choose something simple. I think simple will work best most of the time. So even just something like this, like just a sun HDRI. Let's keep the environment to this. And I think what's important is that try to reduce the color saturation. Then I have like kind of just move this. So you can start to see it's so for something simple like that first. Maybe it would be nice to add a ground plane. Get a little bit more realistic on to use concrete. For yeah, basically I'm just cleaning up this. Just do it without let's copy this material. Basically, what I wanted to create is the effect of like a glass slipper with like translucency in the material. So that's why I'm using mainly this kind of translucent. I'm using let me just set it up and I'll go through. So basically this is just glass, this purple one glass, and this is cloudy plastic. So they are pretty much standard material, not super not super custom, but let me try to add something a little bit more interesting to the render. So especially for the body, it's just a single. I mean, you could add a color. It starts to get more interesting, but what I wanted to do is this kind of quite instantly make things really interesting. So under texture, you do curvature. You can always preview it with you click it on it and press C. So what curvature does is that it adds color depending on the curvature, positive or negative. So this looks like all white and washed off because we haven't made the adjustment. So this starts to get a little bit more interesting. So then you adjust the radius. To have it more blended, then you could just choose different colors. You should definitely have purple because of this purple glass kind of vein, bone vein kind of thing. So maybe something around that region. And as a contrast, you have a bit of green. So this is sort of like a preview, right? So yeah, just a touch of orange for contrast. So kind of like cool colors, a little bit of warm color. So you can add that to the transmission. And when you click C, it will help you with preview. Oops. Yeah, there we go. So maybe we have the rest of this fin body in the same material. I think they're not really showing up because the cloudiness is too transparent. So so thin. So you kind of get this really kind of colors. Like kind of uneven colors you could do for the design. Yeah, I think this might be because of the material is taking a bit longer to display to do the live render. So maybe let me just try something that's a lot more efficient. Let's do glass. Seems to be working. For this, let's do so let's do the brush aluminum to let it really pop. See for this. Glass material. Yeah, so maybe something like that will work. Maybe just hold on a little bit. Hold on a little bit. Let it do a bit of a preview. I'll answer your questions in a bit and just do this so that you can preview that. Maybe okay. Let me answer the question. The whole design is printed as one piece, or the different parts are printed separately, then put together. This is actually a concept design. Concept design is not really meant to be printed, but if you want, you can do that. The way I envision this design for it to be printed is, if it were to be printed, it would be printed in a something that Stratasys, a printer that Stratasys will have. They're able to print in one go with different colors, so like a multicolored, multi-material printer. If you know what I mean. So if you see some of the works done by Neri Oxman, she had like just really colorful and like also like transparent on the outside, and inside sort of like embedded with like colors and different parts. So you could actually print that using that system, but obviously that's not what we can get access to on a regular basis. So if you really want to do it, do this exact design of parts, you could probably do that separately. For example, maybe the interior parts of this kind of like shapes. could be printed separately and kind of insert that back in, and the wings could be also printed in 2 parts. So you can attach them like printed in 2 parts, so you can do the color treatment separately. So it just depends on how you want it, but everything can be printed together, I think, except for that kind of texture part. That would be, you need to print that in a different material for sure. How many cores it has to print different material? Yeah, exactly. So if you're using FDM, you probably couldn't see the inside that clearly, but you probably can try if it has more than one material, so that could work as well. But like resin material, all that, you have to print that separately because it comes in one material only. So yeah, you could do it with like something called a polyjet printer. So it's kind of like a jet printer, it has different materials. So that will work. Then I guess you guys can see like the designs here now. So I also wanted to show a little bit about the rendering. So what I can do is, so I think just if you're using KeyShot, I think there's not a lot to show other than when you kind of play and experiment with it. So I think what would be useful is, I'm not sure everyone does it, but I think you probably do, but I think just in case someone that just started out. When you render, it's good to set this clown pass, because after that you could easily Photoshop. And usually I set maximum time instead of maximum samples. Reason being, with maximum samples, you have no idea how long it will take. With maximum time, you could gauge that based on the time you have. I think that's could be more practical. So that's that. And maybe I can show you how to use the clown pass real quick with KeyShot. I think with with Photoshop. With KeyShot, this is sort of like the result. But this is not really clear. Let me see it. Oh, okay. That's fine. Okay. No problem. Thanks for Cameron. Thanks everyone for joining. So I'll just turn off KeyShot real quick. So I think you get like the gist of it. Let me just quickly do like Photoshop, like maybe 5-10 minutes, and then you guys could go. I'll just show one of the render I had. Yep. Yeah. You guys go ahead if you need. I'll just add a little bit more content so you could like look back at it. Yeah, thanks, Renee. Yeah, no problem. I'm glad you guys like it. So just real quick, if you were to use this, so it's just convenient with this. I'm sure like many of you already do use it. So but just in case, I want to make this look more contrasting and more sharp. So usually I'll just do this is already rendered, so I'll just do a level. But you know, if you do this, you'll be overexposed. So I don't want to do that. Then with the design, the design I wanted to kind of emphasize on the wings itself. So what I'll do is I'll take out magic wand, select these, the wing, and with a brightness pump. So what this is convenient is that because it's difficult to isolate, when you want to Photoshop, you want to isolate parts, right? So if you turn on the clown pass, you can actually do this, and it's so much easier for you to Photoshop. Oh, my bad, my bad. Yes. Yes. So I was saying like that. So I just adjusted these two, just brightness and level. And I say I wanted to kind of emphasize on the wings. I think that's kind of like the center of attention of the design. So with this clown pass, what is useful? You can see, Jerome, you can see the screen already, right? See the screen already. Very cool. So you can see, so basically what I did previously is just, really simple, brightness and contrast. But what I'm saying with the clown pass, when you enable it, what's useful is that, you get this kind of color thing. I mean, very colorful, that's why it's called clown pass. But anyway, what I do is I click this, you could use it as a masking layer. To help you isolate the parts that you want to. So same thing. Let's say on I could do that. Then, for example, I want a bit of texture. Let me go to the stop. Because now the surface seems kind of smooth. I thought it's more adding a little bit more detail makes the render richer. So I'll just select the main base of the body, and this is a texture I just randomly downloaded. This is cool. Almost like a scratch. So I mean, this is too harsh. So, yeah, just manipulate it a little bit. And also to yeah, I wanted to edit this kind of texture on the body itself. I want to make it less obvious, so you can use this so that the focus is more on the fin. Yeah, so Yeah, here you go. Like now I try to do less Photoshop, but I think unless I'm experimenting with the design and not decided yet, usually I do. Usually I don't do as much manipulation. The renders, but usually the rendering turns out well. Maybe I can show you. Since this is sort of done, maybe I can show you a couple of like the renders I did, so you could take a look. I think if you have not seen this on my Instagram, maybe just take a look. Yeah, so I did like a couple ways. So you have this kind of fire-ish, kind of like on the that wings of fin itself in different colorways, and then you kind of have a great gradient. So these I did in Photoshop. And these are like I use like a more translucent material that's more cloudy. They're kind of almost like a skin kind of color. I thought that's quite interesting. I'm using a different pattern of that. Is Canvas more like Material ID? I think so in other rendering software. Yeah, exactly. It's similar to V-Ray. Correct. Canvas is just assign different colors to other materials. Just makes it easy. Yeah, exactly. Yeah, so like lots of different ones. So I just did kind of like exploration. Yeah, so and I think the monochrome one is also pretty nice. Let's for this one. Yeah, something like that is quite cool as well. That's not fully rendered, so yeah. I think this is more or less it. Thanks everyone. If you have more questions, you can let me know. If not, I think we'll be closing. Yeah.
Thank you so much. It was a fantastic webinar. Lots of cool insight and inspiration there. Seems everyone was enjoying themselves.
Yeah, I believe that.
Does anyone have any questions? If anyone wants to ask a question by video or microphone, you can click the raise hand, or you can just ask it in the chat or Q&A. Now would be the time for any kind of last minute questions. I hope you all enjoyed it. I certainly did.
Yeah. Hope you guys enjoyed it. Yeah. As much as I had fun sharing. Yeah.
Yeah. And yeah, make sure that you follow to keep up. And yeah, it seems there's no more questions. So thank you so much, Ping. Everyone else, when the recording is done, the email will be sent, and you already have the files, so that's good. And yeah, and good luck, Ping, on your start of your company. I hope it goes well. The designs are really interesting.
Thank you. Yeah, I think for people who like are gonna try the renders, like it'd be cool to like tag us, tag Design Morphine or me, and we can like I don't
Yeah,
know,
so it'd
post
be
on
great to
that
see
would be
them.
really cool. Yeah, exactly. To see like what kind of results that you guys get.
Yeah. Cool. Well, we'll end it there, and I'll talk to you later, Ping. And for everyone else, see you at the next events.
Yep.
Bye.
Bye. Thank you.